Okay, Mr. Miller here going through the Unit 4, AIM 5 homework, which is on heat calculations. At top, you'll see the 3 formulas we use, so we'll just jump into the problems here. How many joules of heat are given off when 5 grams of water cool from 75 to 25 degrees Celsius? So the easiest way to figure out which equation to use is look for a temperature change. So here we have a temperature change. We're going from 75 degrees Celsius to 25 degrees Celsius. So if there is a temperature change, then you would go through and you would use the formula that has a change of temperature there. There's no change in temperature. Temperature is not even a variable in Q equals MHF or MHV. So we have to use Q equals MC delta T if there's ever a change in temperature. So we have Q equals MC delta T. We're writing out the formula and we're showing work here. So here we've got Q equals MC delta T. The next step is to go and list all of the variables. Q is heat. How many joules of heat are given off? We're going to be calculating that. So Q, you're going to be solving for. The M, mass, you're looking for something that has grams attached to it. So we have 5 grams of water. That's going to be our mass. And now C, the specific heat capacity is C. That is not given for you in this problem, but you could look it up on the reference table. So go to the first page of the reference table, and you're looking for physical properties of water, and you'll see the specific heat capacity of water is 4.18. And then delta T. It would be incorrect if you put in 75 degrees Celsius. It would also be wrong if you put in 25 degrees Celsius. Delta implies a change. So you're looking for the change in temperature between those 2 points. So to get delta T, you just take one, subtract the other. And here we have 50 as our delta T. So now we have all of the variables written down on the side, and we have the formula written out here. So this is what I want you to do before you do any calculation. So here we have our formula. We have all the variables listed, so we're going to start plugging them in. Q is equal to M, which is 5, times 4.118, specific heat, times delta T, which is 50. And we go ahead and plug that into our calculator, and we have 5 times 4.18 times 50, and that gives us 1,045. Make sure you include units on these. You're solving for heat. It asks you how many joules of heat are given off, so you're going to then indicate units there. So that's your final answer for question 1.